So this video, we will see how the iterator will work with our sequence container. We're using the vector, for example. The sequence container in the STL library, including array, we already see that. Vector is very important. So deck actually is in the textbook. It's too much information in this chapter. So if you have interest to see that, you can see the textbook. But here I remove that in the lecture. So we have the list. So then that's the reference information in this handout. You can see the list example at the end. So for the array vector and the deck, they are all based on the building an array. So that's why fundamentally they're still using the array to access the element. Just one thing is the vector kind of like dynamic array. The capacity can be resized. But here we also can just add element one by one, push at the end. So then the list actually is implemented by the linked list structure. So to see the detail how to implement that, you need to refer to the chapter 19. But here in the handout at the end, I only show you how to use the list library for that. So the first thing we see, our example for this one, I want to show you how to use the iterator to work with the vector. So the vector actually we see many times before. So the way I show you before, that's we only using the vector like array. Just we know this vector can resize. So typically we only using the square bracket to access the element one by one. However, vector can use not only use the index to assign the value, we also have a member function called pushback. So the pushback actually just when you're using the pushback on the vector, you will add the data into the next available element to the vector. So if we try to only add the element one by one, use the pushback, we kind of lost track how many elements we have, right? So then if you want to list all the elements, so that's why here we will show you the example too. Besides, we add element one by one using pushback to the vector. We also show you how we can using the const iterator to display the information in the vector. So actually, vector, we have couple more important member function. So here I'll give you the link here. If you want to see all the member function from the vector, please access that. So you will see all the member function we have in the vector. So then we see the example 2. So this example 2, what we want to show you is we were using the array. Okay, so then we're using this array. We're using the array for using the initializer to initialize the array. So also you can see the array actually can use the pointer to traverse element one by one as well. Then we create another vector. You see vector, we need to include the library. So this vector, we don't know the size. So actually they will have the default capacity. So then when you start with the default constructor, so the first thing we see, what is the size for the array? So you will see here, size mean what? Size mean, do you have any element in this vector or not? So that's why we know the size will be 0. So then since you call the default constructor, so then we will see what is the initial capacity in the integer. So actually from my compiler, the initial capacity actually is 0. Sometimes the initial capacity is according to the compiler. So then we see here, after we're using the pushback, you see here, we're just using the pushback. So you see they add 1 element to the vector, 2 element, 3 element, total 3 element to the vector. So the order will be 2, 3, and 4. Okay, so afterward you can see we can display the size and the capacity again. So then you will see the output. So later I will show you the output. We just finished here. Okay, so then we will see after we add 3 elements into the array, So the size we can guess will become 3. But what is the capacity here? Still 3. Okay, so then we see the output until line 29. So you can run your program too. So we see until line 29, see that's our output. When we just create the array with the default constructor, the size and the capacity from my end is 0. So then after I push 3 integer, so then I have size is 3, makes sense. But capacity is what? Yeah, capacity is 4. So most of the time, the algorithm is we start from the capacity is 2. So every time capacity is not big enough, usually they will double that. Okay, so that's the default constructor from the vector. So then we continue to see the example, because the next one we will show you is before when we're using the pointer, right? So then the pointer access the array. So you see values actually is the array. Value is earlier the array we defined. Okay. So then you can using the pointer. So since I want to read only, so I do the constant int pointer. So that's equal to the beginning of the array. So you see end of the array. That's our for loop. When they are not equal to the end of array, they are not going to the end of the element, right? Then I just print one by one. You see, just like before we show you, pointer, when you want to move the element one by one, you just need to do the plus plus. Because here we already specified the data type. So that's why here we will print the result like this. So you see your array can print like that. So the next one, that's print our vector. Okay, but here I want to show you is this one actually we write a print vector function. So we see this function is what? This function actually called print vector. You just passing me a vector. I will display the output for you. But because you know vector is what? Right, vector is a template vector. So if I call the print vector, this print vector function also need to be what? They need to be template. So again, that's another template function because I call the print vector. But I even don't know what data type for my vector is. So that's why you see you have a T. So vector is object I pass in by reference. So then I just want to print, so I do the constant only. So you all learn how to implement template library, right? So can you think about how you implement this print function? Yeah, you can post the videos, think about that. Right, you have many different ways you can implement this template function to print the content for the vector. But one thing is, here we want to show you how to use the iterator to do that. So this earlier we say, since you are the constant vector, so your iterator need to be what? You need to be constant iterator. So that's define a constant iterator, it. Okay, so then this it, you see, after you pass in the vector, so then this it I assign equal to the C begin. Why I do the C begin? Because I need to have the constant begin. So then when it not equal to the constant end, I just plus plus. So when we want to see out, right, remember you don't see out it. You need to see out the reference it. Because it is what? It is an iterator. Now you need to print the content of the vector. So that's why you need to do the reference it. But the most important thing, when you define a constant iterator, right, you need to have a double colon to give them the data type. Otherwise, I don't know what kind of iterator you want me to do. But here, because our vector is the T here, so we don't know the data type yet. So here, when you have an iterator, you don't know the data type. So this vector T, you also need to add a type name before that. So this way is a template iterator, how you will define that. So because from here, you can pass in any data type vector, so I can print the content. So that's why we print the content is 2, 3, and 4. So this one I want to show you is, besides you using the constant iterator and how you will define a template iterator. But if you already know the type, right? So for example, we can write a function, but also we can write in the main function, I want to display reverse content of the vector. Okay, so you will see here, since I already know my vector is the int data type. So when you want to do the constant reverse iterator, you see you just do the constant reverse iterator. We call this RT, actually just mean the variable name. But this constant iterator, you also need to give me the type. So the type, you need to do the double colon because they associate with the class. So then that's the vector container. The data type is int. So that's regularly when you know your data type and you know your object that associate with, you just have the vector and the type here. Double colon constant reverse iterator. So when you reverse, right, so that's why you will do the RT actually equal to the CR begin. Okay, you do the reverse, but you still do the begin because we already calculate that. So then you not equal to the end. So even you do the reverse, remember we say that's the backward. Okay, so then they still do the plus because in the library we already implement like that. Okay, so that's your print. Again, don't forget, you should be the pointer dereference RT to display. So that's why your result reverse will be like this. So the example 2 we show you here with the syntax we use for all the iterator, you should specify your data structure, class, and your data type. That's prior to the C++11. So the good news is after since C++11, we introduced the auto keyword. So that's why here, everything, this one, we can change to the auto. So they will, according to the vector here, you specify they know the data type they can calculate. So the same thing even for the template. So that's why after you do the chapter example 2, I want you to go over, download the example 2 underscore auto. So this auto actually you're using exactly the same data. You have the array 1, 2, 3, 4, 5, 6. You have the vector integer, you push back 2, 3, 4. But the difference is when we print out the information. So when you're using the reverse iterator to do that, you don't need to worry about that. You don't need to have your reverse iterator, the data type defined beginning. You just need to have your iterator reverse name is reverse iterator. So you start from the CR begin. So one thing is here, the data type, you just need to use auto to using that after C++11. So the same thing, if you, this your iterator you want to use, they are in the template function. So then the same thing, you just need to tell me which type of iterator you want to use. So they are accessed by the object name. So according to the object type, the auto will assign correctly for the data type for the constant iterator. So that's the other way for the iterator. If you kind of, after you're familiar with that, so that's after C++11, you can using the auto keyword. So you no longer need to worry about the data type. So I finished the vector example, the first one. So in the second one, example 3, I won't talk about in the video. So I just want you to go over the example. Actually, we talk about in the handout. Okay, so I want you to read by yourself to see in the example 3, we're using the different, we have front, back, we have more member function in the vector. So we have example for the copy. I want you to read through that yourself.